Okay, well, I guess we'll start at Module 3 then, and just kind of look through a few different things from each of the different modules, and just kind of give you an overview of things that you should know. Remember, the review that I'm going through here are ones that are on they're actually on the front page of our home page, or Canvas home page at the bottom. So these are just the reviews that the department puts out. The same people that make the review also write the final. So it gives you kind of an overview of things that you should know, and then it kind of gives you a little bit of an idea of where to focus your efforts, I guess. All right, let's see. Whoops. Do that. All right, you guys believe it's the last day of class too? Wowzers. All right. Okay, so let's look in 3 point. Let's look at number 8 to start off with here in Module 3. So remember, when you're asked to graph something, that it's going to be easiest if you have that in the slope-intercept form, and that's that y equals mx plus b form. So, what's going on with my camera? Okay, I don't know why it's doing this. Sorry. All right, so because when it's in this form, remember, we can easily pick out what the slope is, right? That's our m, and what the y-intercept is. So we like it in this form, right? So like number 8, it's already in that form. And so we said when we graph this, we're going to start with our y-intercept, that -2. And so that's saying on the y-axis, we need to go down 2 places. So we'll put a point there. And then the number in front of the x is our slope, right? So our slope on this, I'm saying it's -3, but really we want to think about it as a fraction. So we're going to write it as -3 over 1. You can always change any number that you have into a fraction, right? And we want that because, remember, our slope is rise over run. So we need to know how far up or down we're going compared to how far left or right we're going, right? So from -2, it's telling me I'm going to go down 3. So 1, 2, 3, and to the right 1. Okay? Or remember, that would be the same thing. We can put the negative with the top or the bottom. So I could say 3 over -1, and that's the same thing as -3, right? And so that, but if we do that, and saying our rise is 3, so from this point we'll go up 3, 1, 2, 3, but this time we're going to the left 1, right? So we've got to notice our signs there, but notice how this is all still on the same line, okay? Now, just pretend that's a straight line. Okay. And that's what the graphing of that line would look like. Right, now, on one of the tests or the quizzes, I remember that there were a lot of people missing how to graph something like this. So I wanted to talk about one like this. So again, we want to get it into that y equals mx plus b form. And it's not in that form because y is not by itself. So let me move this over here. So if we have 2x plus 3y equals 0, to solve for y, I'm going to subtract my 2x over, and then that will give me 3y equals -2x. And if you want to keep that plus 0 there, you can. It kind of, I think, was confusing people because there wasn't a y-intercept. And so that was causing people some problems, right? But we still have more to do. We got to get the y by itself, so I still need to divide everything by 3. So that will leave me with y equals negative 2/3 x, and then 0 divided by anything is just 0, right? So if you leave off that part, sometimes people get confused and like, what am I doing? How do I graph that? Because I don't know the y-intercept. Well, if there's no y-intercept there, then that means the y-intercept is 0, right? So here's my y-intercept, and then this is my slope. Remember, slope doesn't include the x. It's just the number in front of the x. Okay, so on this one, I'm going to start at 0, 0, and then from there, I'm going to go down 2, and then right 3, or I could go up 2 and left 3. And that still is, the same line I have here. Okay, that's what that line would look like. Okay, questions on either of those graphing? How to graph those lines?
Nope.
Okay, let's look at this y equals 4. So remember, when it's saying to graph a line like this, when it's y equals some number, I want to make sure that you remember that that's a horizontal line. Right? And so basically to graph this, we're going to go up 4 places on our y-axis, and then we will make a line there, a horizontal line. And then similarly to that, if you have x equals just some number, that's going to be a vertical line. So in this one, on the x-axis, we're going to go over 2 places and then draw a line up or down there. Okay, so just remember, when it's a vertical line or when it's a horizontal line. Okay. All right, let's look at some of these inequalities, graphing the linear inequalities, because the graphing part is really similar to what we just did, but now we have some shading that we've got to do also on it. So we first need to get it into that y equals mx plus b form. So let me move this over here, and let's solve this to get y by itself. Right, so I'll start this by subtracting the 2 over. And so I'll have y, make sure you keep your sign there, is less than or equal to negative 2x plus 2. And remember, if we multiply or divide by a negative, that would flip the inequality sign the other direction. Right, so make sure that you keep that in mind. That's one of the crucial things with inequalities. Got to remember. Right. And so then again, now that it's in slope-intercept form, I'll go up 2, right? And then my slope is down 2 to the right 1. So down 2 to the right 1, or up 2 to the left 1. And then I need to look and see if it's going to be a solid line or a dotted line. Right? So remember that if it's a solid line, it means it includes it. So that means you would be having a less than or equal to or greater than or equal to. But if it needs to be graphed with a dotted line, that means it doesn't include it, so you wouldn't have the equal to part. Right? So that's going to tell you whether to use a solid line or a dotted line. So on this one, it is going to be solid because we have the equal to part. But we're not done. Oftentimes students stop there and forget that you've got to do some shading at this point, right? So you've got to decide which part of this, the top or the bottom, right, is going to be shaded. Well, it says y is less than or equal to this line. Well, the stuff that is less than the line would be the stuff below it. So that would be the shading that you'd want. It's the stuff on this side. And if you picked any point over here on this side, right, it would make this statement true. But if you tried to pick any point on this side, right, then it would make an untrue statement because none of the points on, that are above the line are going to work. Okay? Those aren't part of our solution. All right. That's just a little bit with remembering about the shading. Okay. Let's talk about parallel and perpendicular a little bit. All right, so we said when we have lines that are parallel, so parallel lines have the same slope, and perpendicular lines have slope.
With the last one.
Say that again?
Quick question with the last one.
Yeah.
Can you use a table for those instead?
Okay, just 1 second. Slopes that are... Okay, slopes that are negative reciprocals. All right, so those are a little bit about slopes. So let's see. So which one?
The one that we just did up there. Are you able to use, so after you change the form to the slope-intercept form, can you just use a table instead?
Of course.
Or...
Yeah, you can always use a table. You pick x's and then figure out what the y's are. This will always work. So
just always change it to the slope-intercept form to make sure that you're shading the right side, correct?
Yep, you gotta change it to the slope-intercept form to make sure, yeah, that correct side's going to be shaded. But yeah, you don't, and then you want to, I mean, it's going to be easier to have it this way anyway, so that when you're putting x's in, you can figure out what your y's are easier. So yeah, so you can use this table of values, right? That's a great way. Or since it's a line, you can use the y-intercept and then the slope with it. So either way, it's not going to say on the test which way you have to graph it. You can just find a way to graph it. Okay? It might ask you to put, you know, might ask you to label or like give 3 points that are on the line. They've done that before. But even with this, like I can see, like after I've done this, I can see, you know, 3 points that I had and put those points in for my answers. What else were you saying?
Nothing. So the way that you did, there's no question that's going to like absolutely require the way that you did instead of the table?
Nope. You can do either way. Yep. Because remember, you're not even turning in any of your work for the final exam. So you'll, you know, put your answers in on Canvas, you know, kind of like our quizzes have been. And, you don't ever submit work to me for those quizzes either. So, but sometimes on this, they have said, like, you know, graph it and then list 3 points or something like that are on the line. So, yeah, so you might have to do that. But if you do a table of values, you'll already have 3 points that you use to plot. So either way works. That's one of the things I love about math is there's more than one right way to think through a problem. But then that can sometimes be confusing for people too, because they're like, wait a minute, you know, I'm thinking through it this way and other person is thinking through it this way. But, you know, try and use it to your advantage and, you know, speak up and ask. Like, I love it when you ask, you know, can I do it this way instead? Because that tells me you're really thinking about what you're trying to do here. Okay. All right, so then on this next part, right, with parallel lines and perpendicular lines, so parallel lines always have the same slope, and perpendicular lines have slopes that are negative reciprocals, right? So, like if I had well, let's look at this first one. I'll probably just do it on this one. So we cannot tell what the slope of the line is until it's in that y equals mx plus b form. So again, I need to kind of manipulate this around, solve it for y, so I can easily see what my slope and my y-intercept are. Whoops, let's see here. So let me write up here. So I've got 4x minus y equals 2. I want to get y by itself, so I'm going to subtract the 4x over. So I'll have negative y equals negative 4x plus 2 but then I still need to divide everything by -1 to get y by itself. So y equals 4x minus 2. All right, so now this is in the form where I can see I've got my y-intercept, I've got my slope, but all I care about on this, when it's saying that I want to know, the slope of the line that's parallel to this, is basically saying what is the slope of this line, right? So the slope of this would be 4. Okay? But what if it asked for perpendicular slope? So a line that's perpendicular to this one would have what slope?
Wouldn't it be 1/4?
Close. There's one other thing you have to have. So you did the reciprocal, but then you also need to change it to its opposite. All right? So since it was a +4, we'll change it to a negative, and then also flip it. Okay? So make sure you remember both of those things. That's so easy, and I'd say that's probably one of the most common things that's missed on the final exam, is people remember to either flip it or change the sign, but forget they have to do both. Okay, so write that down in your notes somewhere so you remember you got to do both of those. Okay. All right, and then what does it mean? So in this next one, it says average rate of change. When it's asking you to find the average rate of change, what is it really asking you? What are we trying to find here? Remember? Average rate of change. Starts with an S. Okay. It's going to be the slope. So when you write down, you definitely should make sure that you know the slope formula. That's going to be one thing that you want to make sure. So have a sheet of paper that you can maybe jot some things on right now, because I'm going to be saying, oh, you got to know this formula. Oh, make sure you know this formula. Even though you're going to be able to look it up because you can use your notes, it'll make it so much faster and easier for you if you have everything all in the same place. So I would make a little formula sheet up of things that you want to know. Okay, so that would be, so one of them is you definitely want to know slope. And in parentheses, I'm going to put average rate of change, because some students miss a question like this because it's saying find the rate of change, and that confuses them and they're not thinking, oh, I need to use the slope formula. So make sure you know that it's the same thing. And that slope formula says this. It says y2 minus y1, right? So you subtract your y's, divided by x2 minus x1. Right? So the change in y over the change in x. So the y's have to be on top and x is on the bottom. It doesn't matter necessarily. Some of you, I think, were using, y1 minus y2 and then x1 minus x2. And that's fine as long as you keep it consistent, right? But this is usually the way the books write it and stuff like that. So just keep it the same way that we've been talking about. All right, so now let's look at number 24. All right, so this one you've got to read really carefully because there's going to be something here that you've got to really notice. Okay, so in 2009, there were 879 jobs in a small town. In 2015, there were 423 jobs in that town. Find the rate of change, and then this is the part I want to make sure that you're thinking of here, in jobs per year, right? Lost, right, because it went down from 2009 to 2015. But that jobs per year, if I was to write that as a fraction, that would say jobs over years, right? Jobs per year. And so that's important because that's, remember we're going to be talking about our slope. So it means our jobs have to be our y's and our years are going to be our x's. So if I was to write these down as ordered pairs, because this is usually how we have these, we have the year, so 2009, comma, 879, right? So there's 1 point. The other point, in 2015, there was 423 jobs, right? But again, making sure, right, you want to have your y's over your x's, right? So your jobs have to be y's. So notice that, because sometimes people get this flip-flopped and they have it upside down and then you miss it. So it's important that you know how to write this. All right, so then if we're thinking of this formula here, I'm going to label these as x1, y1, and x2, y2. Right? And then I'm going to just put that into the slope formula. So I've got 423 minus 879 over 2015 minus 2009. Okay, so I want you to take a minute and try and simplify this as much as you can. Figure out what our slope is here. Okay, so on the top, when you subtract those, you should get negative 456. And on the bottom, when you subtract those, you should get 6. And then when I divide that out, right, because this will simplify further and it actually divides in evenly, we get negative 76. All right, so what does this negative 76 represent? Can somebody just unmute yourself and tell me, what does this mean in this problem, like what we were talking about in this problem?
Is it that they lost 76 jobs per year?
Yeah, exactly. So that negative is telling you that jobs were lost, right? So 76 jobs, right, lost each year. Okay, so make sense of what you're finding. When you have some kind of a story problem, make sure your answer makes sense. And even they give you a little, hint here. It's telling you that it's lost jobs, right? So you know that that's going to end up being a negative, where up here, right, how many new jobs? So I would guess that the answer to this would be a positive answer, right? So just like looking at some of that and making sure that I check that my answer makes sense in that problem is an important skill to have. All right, let's try number 26 now. So this time, right, it wants us to write the equation of a line. And there were two different ways. I know that some of you that watch the videos use this point slope formula. Okay. I mean, that's not the way I talked about it in class, but that's perfectly fine. It'll get you there. So if you like that way better, then use it. Right? And this point slope formula is y minus y1 equals m times x minus x1. Right? So where m is the slope and x1, y1 is a point, thus having the name point slope. We need a point, we need the slope in order to use this formula. Okay, the other one that we talked about is just the slope intercept form. Is just that y equals mx plus b. So you don't actually have to, memorize this other formula. You can just use the y equals mx plus b. but it's totally up to you which way you want to do it. Okay, so let me show you on this first. So first of all, if we're trying to write an equation of a line that's passing through 2 points, we need to know the slope and we need to know a point. Well, they give us a point. In fact, they give us 2, right? But we have at least 1 point. We are not given the slope, but we can find the slope, right, between 2 lines. So that's what we're going to want to start on this one, is we're going to want to find the slope. So we would do negative 14 minus 7 over 3 minus a negative 4, right, which is really adding 4 down there. So I've got negative 21 over positive 7, which will reduce to be negative 3. So this is my slope. All right, so this is part of what I need. So I've got a slope, and I've got a point already. I'll put that over here. So the point that I'm going to use is negative 4, 7. You could use the other one. It doesn't matter which one you pick. Either one is going to get you the same answer. Okay, but yeah, so that's going to be our x and our y. Right, so if we use this slope-intercept form, right, we're just plugging the m, right, the negative 3 in place of m, the negative 4 in place of x, and the 7 in place of y, and then solving for b. So that was one way that we talked about it. So let's do that. So in place of my y, I'm going to put 7 equals, in place of my m, I'll put negative 3, in place of x, I'll put negative 4, and then all I have left for is my b, my y-intercept to solve for. So 7 equals 12 plus b, and then I'll subtract the 12 over. So b equals negative 5. All right, so I'm not done yet. I have to write an equation of a line. All right, so I've got to think, okay, I've got to go back to this y equals mx plus b. All right, and then I'm going to put in what I know here. Let's see. So in place of my b, I'm going to put my negative 5, and in place of my m, I'll put the negative 3. So my answer would be y equals negative 3x, right, minus 5. Okay, so this is doing the slope-intercept form. Or sorry, yeah, slope-intercept form. But if I do the point-slope formula, I'm just going to show you this way because I know some people were doing it this way. So this time, our point that we have, our negative 4, 7, right? We got our x1 and our y1. And so we'll put those in. So I'll have y minus, in place of y1, goes 7, equals m, which we said is negative 3, times x minus x1, which is that negative 4. So minusing a negative 4 is adding 4. Okay? And then to simplify this, I need to distribute through, so y minus 7 equals negative 3x minus 12. And then to get y by itself, I need to add the 7 over. So y equals negative 3x minus 5. All right, so it doesn't matter which way you solve it. You see, you get the same answer either way. So you pick, which way, is easier for you, doing the slope-intercept form or doing the point-slope formula. Right? It's probably whatever way you practiced on your homework and stuff like that might be the easiest for you on that. Okay. All right. I think. All right, I want everybody to try number 28. So this one says, again, we're going to write an equation. And this is one of the most important things to know how to do in this class, to be able to write these linear equations. So write an equation of a line perpendicular to this line and passing through this point. Okay, keeping in mind that you need to know, like the two things you need to know to write an equation of a line is the slope and a point. Okay, so if we don't know what those things are, I want you to go find them first and then write the equation of a line. So let me give you a couple minutes to try it. How would you do 28? Go ahead and work it out on your paper. Okay, when you get your answer to this, I want you to type it into the chat box. Don't press enter yet, okay, but type your equation into the chat box. All right, let's see what you guys did on this. So enter that into the chat box if you haven't yet. What was your equation of a line on this? Okay, and then press enter. Okay, it looks like we mostly got the same thing. So let's look and see what happened. So you're correct that the slope is 1/5, right? We had to flip it and change the sign. So there's our 1/5 slope. And then our point is going to be 15.2. So if I just use my slope-intercept form, that's the way I'm going to show this one, right? So that y equals mx plus b. Then in place of my y, I'm going to put 2. In place of my m, I'll put 1/5. In place of my x, I'll put 15. I'll write it as 15 over 1. And then plus b. All right, so I'm solving for b. So if I simplify this, I get, I get 2 equals, well, 5 divides into 15 3 times, so 3 plus b. And then I need to subtract the 3 over. So b equals -1. Right. And so now I have my slope. Now I have my y-intercept. So y equals 1/5 x minus 1. And that would be your answer there. So good job on that. That's, it's good to just, and if you made a little mistake somewhere, just notice where that mistake was and what you did, and maybe write yourself a little note so that you don't make that same mistake in the other ones. Okay? Questions so far on this? So pretty much to the end here of Module 3. We talked about the stuff there. There's never been anything on the final exams about 3.8 where you're making a prediction and stuff. It's just too hard to, because the answers just can come out kind of different when you're doing that. So they've never put anything like that on there. So I don't think they'll start now. Okay. So let's move on to 4.1 and talk about these systems, right, of linear equations. So when you have 2 equations and 2 variables, we said that there were, some ways that we could solve these, right? We could solve them by graphing, but that had some limitations because, what if we get, what if our answer is like a decimal answer, right? It's not a whole number. Then it's going to be hard to tell exactly what decimal that is. Right? And also if you had like really big numbers, that would make it really hard also. Okay? But what's really happening when you're solving these systems of equations is you're graphing two lines, right? And where they intersect is your answer. This is your solution, right? Where they're intersecting. Right? And so we could solve it by graphing them and see what that point is that they intersect at, or we can do it algebraically by the substitution method or the elimination. Right? Sometimes the elimination is called the addition method. It's the same method. Okay, but these are the three ways that we've talked about. Those of you going on to 1010 next, we'll talk about even another way that we could solve these. Right? So systems of equations you'll see a lot of in your next few classes. All right, so I'm not going to solve one by graphing, but let's go down and look at solving by substitution and by elimination. Right, so substitution is nice to use when you have one of the variables already by itself. Right, so I see y equals all of this stuff. Right, well that means I can substitute all of that stuff in place of y in my other equation. And then I can solve it for x. Right, so, and let me just say this also, on the test, it might ask you to solve a certain way, like solve by substitution, solve by elimination. But again, it doesn't matter which way you do it. You're not going to get docked off if you do it a different way. You'll get the same answer either way, right? And it's not asking for your work, so just know that, okay? So if you like one way better than another, then use that way. All right, so let's put that in there. So that gives me x plus 5 times the other stuff, right? So that negative 2x plus 12. And then equals negative 3. Right? Just putting that negative 2x plus 12 in place of my y. Now let's distribute. Right? Let's distribute that 5 through. So that will give us x minus 10x, then plus 60 equals negative 3. Okay, now we've got to combine some like terms here. So that's negative 9x. And the 60 needs to be moved over to the other side, so let's subtract 60 over there. So I get 9x equals negative 63. And then I just need to divide by 9. So x equals 7. Okay, but remember, I'm not done. And there's some people that stop here and think they're done. Well, that's the x-coordinate. Oops. I want to write x big. Right, so that's the x-coordinate, which we found to be 7. But now we need to go and find the y-coordinate also. So you're only halfway done, right? So I know that 7, right, x equals 7. So I could put that 7 in place of x here and then solve for y. So I'd have y equals negative 2x times 7 plus 12. Y equals negative 14 plus 12. So y is negative 2. So that's my y-coordinate. So the point in which these two graphs intersect each other is at this point, 7 comma negative 2. So if I was to graph them, right, then it would intersect at that point. Questions that have come up in your mind about the substitution method? All right, why don't we do the elimination method then? And let's look at, let's see here. Sure. Well, let's look at 37, and then maybe we'll also look at 38 also, okay? So 37, by doing the elimination method, you want to make sure that you have your equation set up in the form of ax plus by equals c, meaning that your x's and y's are on one side of the equation and that your whole numbers are on the other side. Okay, and we don't have that going on here, so we need to move these around so that is the case. So in the top one, we just really need to subtract that 5y over. All right, I'll write it over here. So I have 3x minus 5y equals negative 28. Right, keeping the negative 28 on this side, all we did was subtract the 5y over. Okay, but then on the second one, we've got these, we've got to just do the distributive property. We have a negative 2 that we need to distribute through. And so when I distribute that through, I get negative 4x plus 2y equals 14. And now the elimination method, where we're trying to add these equations together and make it so that one of them eliminates. If you look up here in the first one, see if we added these together the way they are, it's really nice because you can see right away the y's just automatically eliminate, right? We don't have that going on here. If we add these together, we'll get negative 1x minus 3y, and we don't have one of the variables eliminate. So we've got to make them eliminate. And we do that by multiplying each row by a number. So if I multiply this top row by 4, and then the bottom one by 3, then I'll have 12x on the top and negative 12x on the bottom. And when I add those together, they'll eliminate. Right? So that's how I'm picking what my numbers are going to be that I multiply by. So this one would become 12x minus 20y equals, let's see, what's 4 times 28? 112, and it needs to be negative 112. All right, and then distribute the 3 through. That will give me negative 12x, right, plus 6y equals, and then 3 times 14 gives us 42. Right, and now when I go to add these together, right, I see that my x's eliminate. Right, I was doing that on purpose. But what's left? Well, we've got negative 14y on this side equals, well, what's negative 112, right, plus 42. That'll give us negative 70, and then we'll divide both sides by 14, negative 14. Right, so a negative divided by negative is going to give us a positive, right, and then we'll have 5. All right, so again, we only found part of our answer, right? We found that y is 5. And I know it feels like sometimes you're like, oh, I just did so much though, how am I not done yet? Right, but now we've got to go and find our x. And so you can put it into any of the equations that you had. Maybe I'll just take this, just looks easiest maybe to take my 5 and I'll put it in place of y here, right? And then I can solve that for x. So I'm just looking at this blue equation there. So that would be negative 4x plus 2 times 5 equals 14. So negative 4x plus 10 equals 14. Let's subtract the 10 over. Negative 4x equals 4. So x equals negative 1. So there is my other part of my answer. Okay, how are you guys feeling about the elimination method? So quiet today. girls are so quiet. All right. All right, let's look at one of these story problems, maybe like number 43. So it says the admission fee of an amusement park is $10 for children and $15 for adults. All right, so I'm just going to underline some of this important information. One evening, 537 people attended and $6,265 was collected. How many children and how many adults were admitted? Right, so on this one, notice that, this very last sentence, right? How many children and how many adults were admitted? That means that we're solving for two different things, right? We want to know how many children, so I'm going to call that C, right? This is going to be the children's tickets. And then A is going to be the adult tickets. Okay? And so if I'm thinking about the equations that I'm trying to write, right, I want to just focus on this part that says, if one evening 537 people attended, right? So our first equation that we have is just going to be talking about, the people that attended. So we don't know how many children there were, so we're going to call that C. We don't know how many adults there were, we'll call that A, but we know together, when we add them together, there were 537 people. Right? We just don't know how many each. All right, then our second equation is going to use the money, right? Because we're talking about the cost, right, or the price on this. And so I'm just going to put down like total. This says it's like revenue, right? Total money coming in. So that means, so we know that there would cost $10 for children. So we're going to say 10 times however many children there were, plus 15 times however many adults there are. Again, we don't know how many that is, but we know that they're charging $15 for every adult. And then this is going to equal the total amount that was collected, right? So that's 6,265. All right, so we've talked about both types of methods. We've talked about the substitution method. We've talked about the elimination method. I want you, now that we have set this up together, I want you to solve this using either method. I don't care which method you want to do, okay, but go ahead and try and solve that using either the substitution or elimination. Okay, so when I worked through this, I found there was 179 adult tickets that were sold. And you may have solved for children's tickets first, and that's just fine, but still in the end, you should come up with 179 for adult tickets. And then when I know that one, remember I can substitute that in place of A. So I'd have, going back to that green equation up there, I've got C plus 179 equals 537. So really we just need to subtract that, right? We know that there's 537 people altogether. And if 179 of them are adults, then the remainder of them must be kids, right? So it looks like we're going to end up with 358 children's tickets. Okay, is that what you guys got there? Any questions? How to set those kind of up, right? Knowing how to do some kind of, these kind of story problems. All right, and this type of one is usually kind of like to pick. All right, let's see. So that is it on Module 4. So let's now go to Module 5 and talk about these. And remember with Module 5, we talked a lot about properties of exponents in there. So making sure that you know those properties of exponents really well, right? When they're connected by multiplication, you add the exponents. When you're connected by division, you subtract it. When it's a power raised to a power, you multiply, right? And so on. So make sure that you're doing that. Okay, I want to look at, let's do number 3 first here. Because remember, you're distributing that power of 3 to everybody, but oftentimes people forget to give it to the number that's out there also. Okay, this is just a common mistake that happens. So I'm going to write it down this way. So it's going to be 4 to the 3rd power times x to the 8th, right? And then when it's a power raised to a power, we're multiplying those together, right? So we'll do the 8 times 3. Then y to the 9 times 3 power, and z to the 10 times 3 power. And so then when we simplify that, right, 4 to the 3rd power, 4 times 4 times 4 is 64. And then we have x to the 24th, y to the 27th, and z to the 30th. And that would be your answer. Okay? So just make sure you remember to give that power to that first guy. For some reason, that one gets forgotten about. Okay. All right, we're going to do some of these ones that are have a little bit more to them than others that have like more than one property that you're using in it. All right, let's look at, we'll do number 6 also. So this one, you want to simplify, right? You want to simplify the fraction. So you're looking at that 21 and 39, right? And you're trying to see if there's a common factor that would go into both of those. Let me rewrite this out here where it will be bigger. Right, so 3 will divide into both of these guys, right? 3 divides into this 7 times and into 39 13 times. So I know that over here, right, for my numbers instead, I'm going to have 7 over 13. That's how that simplifies. Now I need to look at my x's, and I need to get my x's together, right? And I see there's 11 on the top, 8 on the bottom. So there's more on the top. How many more are there? Well, there's 3 more. So x to the 3rd is going to be on top. Right? So similar with the y's. Right, I'm going to look at these. Right, there's more y's on top than there are on bottom. How many more? There's 5 more. So y to the 5th is on the top. And so that would be your simplified answer there. Right? So when you're dividing, right, you're subtracting those exponents. Right? 11 minus 8 gives us a 3. 12 minus 5, or 7 gives us the 5. All right, let's move on to ones with some negative exponents, because that tends to be where a lot of people need some extra help. All right, so let's look at number 15 here. So remember, when I have negative exponents, I want to move them to where they're going to be happy. All right, now this 7 is not like connected with that a to the third. I mean, it is. It's connected by multiplication, but they don't move together, right? They move separately. So, and then on the bottom, I have 7 to the negative 1 power times a to the negative 4th and b to the 2nd. So let's first just start moving things around to where they're going to be happy, right? So that b up top wants to come downstairs. That 7 that's downstairs wants to go up. And this a downstairs also wants to go up. Okay, so then when I write that down, let me rewrite these so that now I have all positive exponents. All right, so I'll have my 7 that was already on top times by my other 7 that I'm bringing up top. Right? It's 7 to the first power, but that first power is not going to change anything. Right, then I had an a to the third already up there, but I'm bringing up that a to the fourth. And then I already have a b to the second downstairs, and I'm moving down that other b to the fifth. Right, so I'm just kind of moving things around here, get them to where they want to be, so they'll be happy. All right, so 7 times 7 is 49. A to the third times a to the fourth. We're going to add those exponents, so a to the 7th. And then same thing on the bottom, we get b to the 7th. 2 plus 5 is 7. And so that would be your answer, all simplified, right? We don't have any negative exponents left. Our a's are together, our b's are together, and that's what we need to do there. Okay. All right, let's try number 16 also. So why don't you guys try and work through that one and see what you get there. You know, I may have started off this different than the way you did it, but in the end, it should all, you know, be the same. It doesn't matter the order that you do it in. So meaning some of you maybe distributed that power of -3 to everybody first. I just don't usually like to, you know, distribute the negatives, because then it just gives you more negatives in there and it just causes a lot of problems usually. So I wanted to start by flipping it. So all of this inside the parentheses is going to go downstairs. And notice that that -4 is still a -4. That doesn't change yet. The only one that was changing was the one on the outside, right? That's no longer a -3. It's now a +3. And then same thing, all the stuff that used to be in the bottom, and now moved upstairs, right? But now it's raised to a +3 power. Okay. And so then if I look at this and try and simplify this more, now I'm actually going to distribute my power of 3 to everybody. So I'll have x to the 15th, y to the 15th, z to the 15th. And then on the bottom, remember again, I'm still distributing that power of 3 to everybody. So 3 to the 3rd power, x to the -12th power, and y to the 6th power. All right, now I've got something that's negative, right? So that x is unhappy down there, wants to go upstairs. I'm going to move it upstairs. And then I also need to do some simplifying here. All right, so I've got x to the 15th times x to the 12th. Right, I've moved upstairs. Y to the 15th and z to the 15th. On the bottom, 3 times 3 times 3 is 27. So let's simplify that. And then y to the 6th. And so now we just need to get some things together that go together. So I can see, all right, I've got x's, all right, and I'm going to add those together. I've got some y's that I need to put together. So I'll subtract those. And then there's nothing, like the 27 doesn't have anybody to reduce with, and there's no other z's. Right, so those are the only things I need to get together there. So I get x to the 27th, right, when I subtract these, right, y to the 9th, and then z to the 15th, and then I still have my 27 on the bottom. So that would be my answer. Okay, so hopefully you were able to get there, even if you did things in a different order. Right. Questions on that one? I can help you understand any better. All right, let's try number 18. If we were to write that into scientific notation, remember we said in scientific notation our decimal point needs to be, it would have to be between our 6 and our 4 here, because our number has to be a number between 1 and 10. So I want to move this decimal point 1, 2, 3, 4, 5 places to the left. So that means I'd have 6.49, right, because that's where I moved my decimal to, times 10 to the, now I got to think about, the power that we're raising to. We moved it 5 places, but notice how this is a really small number. It might have a lot of digits in it, but it's really teeny tiny. So that means it's raising to a negative exponent. Right? So that would be to the -5th power. So just remember some things about scientific notation. Like that. And do some reviewing over some of that scientific notation stuff. Let's do some square roots, and cubed roots, and fourth roots, and stuff like that. Okay, so if we're looking at this one, right, and you can use your calculators to help you figure these out, but notice that this top one's saying like -1 times the square root of 256. All right, so you would just be putting in your calculator, what's the square root of 256? right? And that's going to give you 16. But then we still have to times it by that negative 1. So we have negative 1 times 16. So negative 16 would be our answer there. Okay, so it's okay to have a negative on the outside, but notice on 28 we've got this negative on the inside. And if you try and on your calculator take the square root of negative 25, it's going to say like error or domain error, because you can't take the square root of a negative number and end up with a real number. So we're just going to say that this one is not a real number. Or DNE, right, does not exist. Okay. But what about this one, number 30? So this one's saying do the cubed root of negative 216. And again, most your calculators, make sure you know how to find that, cubed root or something on there. So if you did the cubed root, let's see here, of negative 216, it will actually give you an answer, and it'll be a negative number, because that's saying, it gives us negative 6, because remember what it's saying here is negative 6 times negative 6 times negative 6 is that negative 216. So when you have three numbers multiplied together, you can, get a negative number like we have here. It's just when we have three numbers. When we had two numbers, we couldn't do that. We're thinking what times what that's the same number equals negative 25. There's nothing. You can't say negative 5 times negative 5, because a negative times a negative gives us a positive, right? And we can't say one's positive and one's negative, because they have to be the same number. So there's just nothing that works for that. That's why this is not a real number. Where down here, you can find an answer for it. Okay. All right, let's look at some more that have like the variables and stuff in them too. Make sure that we know how to do these. All right, so let's look at number 34. So we have 108, and so we're going to want to take that 108 and we want to break it down into its prime factorizations. So if you're not quite sure, what number, divides into it, well, you can start with 2, because you can see that it ends in an even number. So 108 divided by 2 is going to give us 54. So 2 times 54 is our 108. Then let's keep breaking that down. It still ends in an even number. So I'll go 2 times what? 2 times 27. And then 27 breaks down to 3 times 9. 9 breaks down to 3 times 3. All right, so when we are dealing with this, all right, I'm going to just write these out in here so you can see. So really, 108 would be the same thing as saying 2 times 2 times 3 times 3 times 3. But since this is a square root, things need to come out in groups of 2. So meaning I can bring a 2 out, all right? So I have to have 2 of the same in order for it to come out as the 2. Then I also have a pair of 3s,